Now talking about associative property. For example, there are three vectors: vector A, vector B, vector C. Now first of all, proving A plus B, then C. Vector A plus B, then we'll add vector C. Vector A, firstly we'll draw vector A, then vector B, vector B will be on the head of vector A, means the tail of second vector will be on the head of first vector, so it will be vector B. First of all, we'll only add these. Now this will be the resultant vector, and we can say the resultant vector is the addition of vector A plus vector B. Now we got a result of vector A plus vector B. Now we'll add vector C into the result of vector A and vector B. Now here vector C, the tail of vector C will be on the head of the resultant vector. This is C. So the C is adding into the result of vector A plus vector B. Now this will be its resultant vector. Now the resultant vector will be, this side will be adding this side and this side. We can write this vector A plus vector B. The result of vector A plus vector C is the result, means the resultant vector is the addition of the resultant of vector A plus vector B and plus vector C. So that is the first proof that vector addition follows the associative, means obey the associative property. So this will be the resultant vector is equal to vector A plus vector B, then the result of vector A plus B we have add vector C. So either we can do this now. If in second step, if we add vector B and C, then in the result of this we will add vector A. Is this equal to the resultant vector? Let us see. Now these were the three vectors. First of all, we'll add vector B and vector C. This is vector B. Now the second vector the tail of second vector will be joined on the head of first vector. So it will be C vector. It is now in the result of this, the resultant vector will be, we can say the resultant vector is equal to vector B plus vector C, because we are adding vector B plus C. Now after getting the result of vector B plus C, we will add vector A. Now vector A will be on the head of the resultant vector. We have drawn here vector A. Now vector A is added in the result of vector B plus vector C, so that will be its resultant vector. Now what will be the resultant vector here? The resultant vector here will be the result of the addition of vector B plus vector C, and then we have added vector A, so that will be its resultant vector. So either we can add vector A, vector B first, then we can add vector C, or either we can add vector B plus C, then vector A. Both the result will be same. The resultant vector will be same. So that what associative property is, either the result of this or either the result of this, that will be same. So the vector addition follows both properties, commutative property and associative property. But a main thing that only the vector addition follows these properties. The subtraction of vector will not obey these two properties, the commutative property and associative property. That can be a main MCQ, that the subtraction of vector does not follow or obey these properties, commutative property and associative property.